This lesson covers an introduction to domain name services, or DNS. Previously, we looked at configuring a computer with a host name. For example, savdaldco1, test server, and then also we configured a primary DNS suffix, or in the case of joining Active Directory, it would be the name of the Active Directory domain, i.e. saviltech.net. So we have its host name and then the DNS suffix, i.e. its parent domain name. When you put these two together, you get its fully qualified domain name, i.e. in this case savdaldco1.saviltech.net. Now, we also saw in previous lessons that each machine communicating on an IP network has an IPv4 address. But to actually communicate between boxes, its MAC address has to be found, and this was done using the Address Resolution Protocol. But in the same way that we have to map an IP address to a MAC address, as human beings, we're really not used to dealing with IP addresses. If we manage 100 servers, it's very difficult to remember, well, that server is 192.168.1.54, that one is another address, etc. So we like a friendly name, something that as humans we understand. That's the same for computers. So typically we like to use this full computer name, this fully qualified domain name. However, when we leverage these names, there's no way for our machines to actually know, well, which IP address actually owns the name I'm typing in. So for example, when I go to a web browser and type http://www.infiniteskills.com, it needs to find out what the IP address of that address is. And so the way this works is it uses domain name services. A query is actually sent to our DNS server, which resolves that name. This is the same as our address book concept. So if I wish to send a letter to John Saville, I need to know his address. So I have to do a lookup in the address book. It tells me, well, this is the actual address it lives at. And then I can send that letter through the various gateways, the MAC address conversion happens in the background, etc. This is exactly what DNS does. If I wish to actually communicate to a server, I have to find out its IP address. And so behind the scenes, that lookup occurs. So when I try and go to www.infiniteskills.com, what actually happens is that is converted to an IP address, and the domain name services performs that for us. Now, just a quick note when you think about naming your servers. I've been to many environments where servers are named things like Thor and Odin and Daredevil, whatever. And that can be fun when you have a few servers, but if you think you're managing hundreds of boxes, those sort of names are very unintuitive. It's going to be very hard to work out which server I'm actually connected to. So my recommendation is to actually use server names that actually relate to the name and location of a server. For example, I would think about using maybe the first 3 characters of the name of the company. This protects you in the future if, for example, your company merges with another company. Then maybe 3 characters for the location, maybe 2 characters for the type of server, and then 3 characters to identify unique instances. For example, if I look at all of my servers, you can see I use a fairly standard naming. Sav for my company, Dal for the location, and then the type of server. Now I don't always use 2 characters, sometimes I use 3. You can see domain controller, configuration manager, data protection manager, exchange, file server, operations manager, remote desktop services. So it gives me a very easy idea of what that server is actually doing. So I do recommend you go with a standard naming for your host to really make it easy to understand, well, what is that server's function, and easy to actually remember when I wish to connect to a server. Now, if you consider the number of servers out there on the internet, and maybe even in your organization, maybe you have a very large company, lots of different domains, lots of DNS domains, it's really not possible for every DNS server in the world to have a list of every single host to IP address record. It would not be infinite, but way too large to be maintainable. So the reality is DNS is a hierarchical namespace. For example, if you think about a typical name, maybe it's www.infiniteskills.com. The reality is there are different DNS servers at each of those domain levels. So we have the top level domains, for example, .com, .net, .co.uk. And there are a set of DNS servers that just handle resolutions, for example, .com. And when you query for example, infiniteskills.com, When you query those .com servers, it points you to the DNS servers that look after the infiniteskills.com DNS zone. So it's an iterative process. As you can see here, if I'm a client and I'm doing a search for what is www.saviltech.com, I ping my local DNS server. My local DNS server doesn't even know, well, where is .com? So a list of root servers that are standards throughout the internet, and it makes a request for www.saviltech.com. That root server has no idea about saviltech.com, but it does know who manages the DNS servers for .com. So it sends me a referral back. This is the IP address for the DNS servers for .com. I then make another request for www.saviltech.com to those servers return to me. Again, it has no idea about the www.saviltech.com, but it knows who the DNS server is for saviltech.com. So it sends me a referral for saviltech.com, the IP address of the DNS servers for saviltech.com. I then go and resend that query for www.saviltech.com to the Saviltech servers, and then I get my response. So this is how it works. There are DNS servers for each part of the domain. Now, if I look at my DNS server here, I can actually see as part of my local DNS server in my environment's configuration, it has this root hints tab. So root hints tells it, well, who are all those primary DNS servers out there on the internet? They're maintained by different companies and they're geographically distributed. So when it needs to discover, well, who is .com, it's going to use one of these and say, well, who owns .com? Who owns .net? And then it can actually work out, okay, well, who do I go to next? Now, the reality is as well, your company is unlikely to want to do all of that working out for every single query. So typically, you're going to have forwarders. And the forwarders may be DNS servers of your ISP, the people who give you connectivity to the internet. Because if you consider what happens, very frequently, you're going to be making the same DNS lookup time and time again. Now, locally on your server, you'll do caching. So I can actually see lookups that I've done before. And it caches those. So if a client requests that NS lookup that's already been performed in the past, rather than having to go and re-query all the DNS servers, it can just use it from its cache. And these records have a time to live. So they only last for a certain period of time. Now, your ISP has very, very large DNS servers and does its own caching. So for the most expedient response, I'm actually going to want to ask my ISP's DNS servers for responses first and let that server ask the .coms, the .microsoft, etc. on my behalf. So it's really the highest performance. But to get some idea of really what these transactions look like, again, let me look at the properties and look at some of these root hints. So I'm actually going to pretend I'm a DNS server being queried by a client. So I'm going to run the nslookup command. And what I'm going to do initially is I'm going to set my server. So this is setting who is the DNS server I'm currently talking to. And I'm just going to pick one, really at random. So now I've set my server to one of those root hint servers. And I'm going to ask it, well, look, who is saviltech.com? Now it has no idea, but what it does know is, well, here's who owns .com. So now what I'm going to do is I'm going to set my server to one of these. So now I'm going to say server. So this is now pointing to the com servers. So I'm now pointing to the people who know about the com DNS space. I'm then going to ask them again, well, who is saviltech.com? They still don't know, but this time the com servers know, well, these are the DNS servers registered to look after saviltech.com. So now it's pointed me to those servers. So now if I set my DNS server to one of these, which is the Network Solutions DNS servers who host my site, if I request it again, now I get the response. And this is exactly what is happening out there on the internet. I request my www.saviltech.com. The root servers have no idea, but it passes me to com. I then query the com servers for the same name. They don't know, but they can pass me one more level down. They can pass me to saviltech.com, and then I query them and I get the actual result. So this hierarchical namespace is what enables DNS to function.